what this is essentially is a measurement of a force that is being applied to your sample. So wherever there is some kind of subjective measurement that needs to take place, this will quantify a subjective measurement. For instance, if I had to tell you, break this in half. Right? If you break it in half, how much force will you need to apply to that stick in order for it to break?
As a value, I don't know.
Exactly.
So,
So, in your QC and in your laboratory, you need to place a value on this, and this is where this machine comes into play. Right? So, if you recall from Elmin's presentation, with thicker and non-flowing liquids, it's a bit more difficult to measure viscosity. And obviously, when you're doing QC, your tolerances are a lot wider as well, because it just doesn't flow, right? So even with your helipad system in your T-bus middle, the viscosity value that you're getting from that is not an absolute definitive viscosity.
Okay.
It's still a ballpark figure with that fixture.
Okay.
So for QC, it's good, but all you're getting from that is a ballpark viscosity figure. It's not an absolute figure.
Yeah.
With this, you can quantify it a lot more.
Okay.
Right? And that's the basis of this machine. So for any sample that doesn't flow, this would be a good option in QC labs. And then obviously we go into solids, things like lipsticks and stuff that doesn't bend or break very easily. This will do the test, right? And give you a quantifiable measurement. So currently what we have here connected to the machine is a 5 kilogram load cell. So you have different ranges of load cells. It goes right up to 100 kilograms, depending on the type of application you're going to use the machine for. But generally 5 kilograms or 50 kilograms, you're going to cover a wide range of samples. Right? Okay, so let's move on to the fixtures. So Brookfield has a massive range of fixtures. In fact, it's almost infinite. So this is what we would supply to you guys as a starting point for measuring of your sample and getting some data from your sample. This is like a cutting blade. This would be used generally for cheeses.
Yeah.
You know.
Yes.
This measures the force of a knife on something. This is also for cutting as well. You see it has that point on the end, so this will cut into the sample as well. We have a lot of these flat discs that would apply specific pressure to a sample. This is more for samples that have a high elasticity.
Okay.
So like things like stress ball,
Yes.
you know, you squeeze it and it
Yes.
must return to its original volume.
Yes.
This would be a good test for that, you know, to ascertain how soft or hard your stress ball
Yes.
is.
Yes.
This fixture, for instance, this likens the pressure of your thumb on something. So we can possibly use this on some of this PJ to determine how much force you need to disrupt it with your thumb, like trying to pull some out with your thumb. So the possibilities are endless, and also what Brookfield also does is that if we cannot supply you with a fixture, we can custom make it for you. Yeah, because it's a subjective measurement.
Yes.
So obviously now if you have some other tensiometer that you want to do the same test on that sample with,
Yeah.
you're not going to get the same results on that
Yes.
different machine,
Yeah.
because this is this one.
Yes.
Okay, so let's test the sterility of the sunscreen. So with sunscreen, this is pseudoplastic in nature. So this has a shear thinning behavior, right? So when you apply it to your skin, the more you rub it in, the more it gets absorbed and the layer becomes less thinner and the viscosity will change. Right? So you're looking here at spreadability, how easy it is to spread it on your screen.
Yeah.
The adhesiveness, the stickiness of it.
Yes.
You know? And this can actually give you a quantifiable value for that. Right. So let's add some sunscreen to this. Okay, we just make sure that we don't have a lot of air in the sunscreen because that will compromise the analysis. So as I'm adding it, I'm just trying to release whatever air bubbles is in there. Right. That's all good. And then I'll just use this flat section of this spatula just to smooth it off.
So it needs to be completely full.
Completely full, full right at the top and flat. Right? And that will give you, and this must be for every sample, so you get that most
Yes.
representative and repeatable result that you're looking for. Okay, so the test fixture that we have here is, we're testing for spreadability, so this is called the spreadability test fixture. We have a cone-shaped probe that will go into this little cup that basically is the same shape as your cone.
Yes.
Right? Okay. Just go back. So you can use the machine in either standalone mode or you can use it with software. The advantages of software is that there's more possibility of data analysis. You can analyze your force curves at every point of measurement. With this one, you can still have a look at the curve and things, but with standalone, you're just going to look for that specific number. So more for QC, standalone, if you're going to do more R&D, go to software. Right? Okay, so it's very easy to configure the test. Just click on that. Right. So the first thing it asks you is whether you want a compression test, a tension test, or you want to maintain at a specific load, or you want to stop at a load. So for spreadability, we're looking to compress the sample, right? So this probe is going to go into that sample and compress it. Right? So we're going to select a compression test. Okay. So these are the settings that you will input into your machine to get a specific value. These specific settings must remain constant. If you're going to be testing your sunscreen and you're happy with these settings, you use these settings for your sunscreen continuously. Okay, so test type compression, as we said before, the trigger value of 2 grams, that's based on the kind of load cell that you're using. So for instance, with a 5 gram load cell, I got it set to 2 grams because obviously with a 5 gram, it's a lot more sensitive than if you have to use a 50 kilogram load cell.
Yeah.
Right? So maybe with a 50 kilogram load cell, you're looking at about a trigger value of 20 grams. So what that means is the sample, the probe will move downwards towards the sample. When it senses a force value of greater than 2 grams, it automatically starts its analysis. It will then analyze and move a length defined by a deformation value. So it'll touch the edge, it'll get that 2 kilogram force value. It'll then move 15 millimeters into your sample, all right, and then it'll come out. Okay, so that's what we do. So deformation 15 millimeters, test speed 2 millimeters per second. So what that means is that per second, this probe will move downwards a value of 2 millimeters per second. Right? I just need to change something here. Post-test value will also make that 2 millimeters. Okay. So that's your basic parameters. Done. Set. Right? Next, what we'll do is I just want to so we make the test a lot quicker. I'm just going to go back to the menu, adjust the beam. Okay, so we'll just set a top limit. Make that 60. Okay, so once we all set, go back to menu, and then we can press start. Okay, so we're moving downwards. You see a load value is below 2 grams there. All right. Once it touches that sample, it's going to sense a force being applied to the probe. And you hear a beep. You hear that beep. So now it's going into the sample. It's analyzing the forces involved. It's going down 15 millimeters, and it comes back up.
Sticky.
Yeah, that's actually my fault. I was supposed to secure it. But we can just do another test very quickly. Okay. So let's first look at the graphs, right? Sure. So this is the force being applied over time. Right, but we'll look at the deformation first, right? Okay, so you see,
It's going back sometimes.
yeah, we messed it up a bit because
Yes.
see, it went into the sample. You got that peak load there. So that's the amount of force that you would need to apply to your skin in order to spread out the sunscreen.
Yeah.
Let's do another test because I just want to show you a better graph.